All right, this is the first in 3 examples of uniform series problems, or also known as annuity. What I'd suggest you do on each of these problems that we're going to go through is pause the video after I discuss the setup or after you read the slide, see if you can solve it yourself based on your reading and the other videos that you've watched, and then go forward the video to see what the solution is. All right, so the setup for this one is you're buying a car for $25,000 with no money down, and so that seems pretty reasonable for a car price. Okay, maybe a nicer car, but something you might be doing. So this would be of your personal interest possibly as well. And you're going to pay for the car over 5 years with 60 equal monthly payments. So 5 years times 12 months a year, 60 equal monthly payments. And that's probably pretty reasonable for a car loan payment, or for car loan length as far as I know. I'm not so sure if 6% per year is what the market is bearing right now, but you'll be able to figure it out on your own given the conditions when you go to buy a car. All right, so we're buying a car. We have a present value of $25,000. We always want to have a cash flow diagram with every problem that we do. If you do not have a cash flow diagram on quizzes or exams, you won't get full credit for the problem because it helps you to visualize the problem and make solving it easier and a higher probability of getting it accurate. So we have $25,000. This is from the viewpoint of the car dealership. So $25,000 goes out, and then we're going to find out what is the monthly payment over 60 months. That is the economic equivalence given 6% per year. So we're going to try to find what is that car payment. So you can see we have our car payment, our initial investment going out, and then the money going back into the car dealership, and we show the dashed lines because that's the unknown in the cash flow diagram. We have our length of time is 60, and we have our interest rate is 6. So we know it's 6% per year compounded monthly. So the question that we're ultimately trying to solve is, what is your monthly loan payment? So the first thing you're going to need to figure out is, what interest rate are you going to use? So let's use this as a quick review of nominal versus effective interest rate. So what is the nominal interest rate we're going to answer? What is the effective annual, even though I don't say annual here, it's almost always effective annual interest rate. And what is the interest rate for the compounding period? So why don't you see if you can come up with that. Press pause right now, and then I'll go through it. Okay, so what is the nominal annual interest rate? Well, that's the 6% per year. It's given as 6% per year. We know that's nominal because that doesn't take any compounding into effect. It's just 6% per year. So what is the effective interest rate? We're going to need to use our formula. 1 plus the nominal annual divided by the number of compounding periods in the year, all of that raised to the power of the number of compounding periods in the year minus 1. So remember, this M in this formula does not stand for months. It stands for the number, represents the number of compounding periods within the year. So in this case, we have 6%, we put it as a decimal, 6% per year, divided by 12 because we compound it monthly and there are 12 months in a year, raised to the 12th power minus 1 gives us 6.2%. We knew that the effective annual interest rate would be higher than 6% because compounding took place during the year, and we know that compounding is going to increase that rate. The effective annual rate will always be higher than the nominal if there's any compounding that's taking place within the year. Okay, so then our last question here, what is the interest regarding interest rate? What is the interest rate for the compounding period? So we know our compounding period is monthly, so what is our monthly interest rate? And we find that by just taking 6% per year divided by 12 months in a year. So it's 0.5% per month. And that is the nominal interest rate per month. I use the word nominal because that means the interest rate for the period where no compounding is taking place. Okay, so it's 0.5% per month. So now we can figure out what our monthly loan payment is. So maybe you might want to press pause again. Oh, well, actually, let's see what interest rate are we going to want to use. Are we going to want to use 6% per year? Well, we're looking at monthly loan payments. So could we use an annual interest rate when we're talking about monthly payments? I don't think so. So then that means that strikes out the effective annual interest rate, because again, this effective annual that's interesting, but we have monthly payments. So what we need is a monthly interest rate, which is this 0.5%. So 0.5% is going to be the correct interest rate to use to find out what our monthly payment is going to be. So now you might want to press pause to see if you can figure this out based on the reading and the other videos that you've looked at. Moving on, then, what we are trying to do here again is, as we stated up here, we're trying to find the annuity given the present. So we know, let's see here, I probably should just shrink this down. We know that from the book that we can find the annuity by taking the present value and multiplying it by this functional notation in the words of engineeringintrainingexam.com guy videos. And you can also use the formulas that are in the book that's in the front. They're in Chapter 4, I believe, but all of the formulas you need are in the front cover of your book. For the annuities, I definitely prefer the functional notation. It's much easier, so that's what we're going to go through here. So we're trying to find the annuity given the present at our stated interest rate of 0.5% over 60 periods. So I know my present value is $25,000 because that was given. I'm buying a car today at time 0 for $25,000. And how I find this factor is I go to the compound interest tables, which are in Appendix C in your text, and I is 0.5%. So you go to the page where the interest rate is 0.5%. Then you go to the row where n equals 60 for 60 periods, and then you follow that over to the column that is finding the annuity given the present. So if you do that, and I highly suggest that you do that right now, go get your book, you will see that that factor is 0.0193. Now if you plug this interest rate of 0.5% and the n of 60 into the actual formula, that is again at the front of your book, front cover of your book, you'll get this exact same number. So the compound interest tables are just purely for our convenience, rather than doing that calculation ourselves. So it's 0.0193. So if I take my present value of $25,000 and I multiply it by the factor of 0.0193, that tells me that my car payment is going to be $483 a month. So this A is $483 a month. And what that means is that I am the car dealership, let's say, and you as well, are economically indifferent to $25,000 today or $483 a month over 60 months given a 6% a year interest rate. Those are economically equivalent cash flows. All right, so hopefully that worked out for you, and we'll move on to the next two examples.